Hi, in this video I will talk about electric charges and Coulomb's law. As we know, all matter is made up of atoms, and atom consists of three elementary particles: electrons, protons and neutrons. Electrons and protons have some properties which cannot be explained on the basis of mass. All particles, according to universal law of gravitation, should attract each other, and the force of attraction between those two particles is given by this expression, where G is the universal gravitational constant, M1 and M2 are the masses of those two objects, and R is the distance between those two objects. Since electrons also have mass, so they should also obey universal law of gravitation. So let's take two electrons and separate them by a distance of 1 meter. The gravitational force of attraction between these two electrons is given by this expression, where G again is the universal gravitational constant and ME represents the mass of electrons and R is the distance between them. So substituting the values, we will get the value of G is 6.67 times 10 to the minus 11. The mass of electron is 9.1 times 10 to the minus 31 kilogram, and the distance is 1 meter. So the force of attraction, the gravitational force of attraction between two electrons turns out to be 5.5 times 10 to the minus 71 Newton. This is the force of attraction between two electrons. But in reality, two electrons repel each other, and the force of repulsion between those two electrons is 2.3 times 10 to the minus 28 Newton. Similarly, protons also have mass, so they should also obey universal law of gravitation, and they should also attract each other. But in reality, two protons also repel each other. So we say that there is some another property which is giving rise to these repulsion forces, and that property is what we call electric charge. So what is charge? It is a property by which certain interactions of fundamental particles can be described. Now, since two electrons repel each other, it means they have the property of charge. Similarly, to protons also repel each other, it means they also have the property of charge. But when you take one electron and one proton, then they start attracting each other. It means the nature of charge on a proton and the nature of charge on an electron is opposite. So we say that the charge on an electron is negative and the charge on a proton is positive, because positive and negative are opposite of each other. Or you can take the charge of a proton to be positive and the charge of an electron to be positive and the charge of a proton to be negative. But since this is standard convention, so it's better to stick with this. Now people have experimentally calculated the values of charges on electrons and protons. The charge on electron is 1.6 times 10 to the minus 19 Coulomb, and the charge on proton is 1.6 times 10 to the minus 19 Coulomb, where Coulomb is the SI unit in which we measure charge. Now the charge on an electron is taken as negative and the charge on a proton is taken as positive. Why? Because of this convention. We have taken the charge of a proton to be negative and the charge of an electron to be negative and the charge of a proton to be positive. Here positive and negative are used to differentiate that the nature of charge of an electron and the nature of charge on a proton is opposite. Here positive and negative does not mean that the charge of an electron is less than the charge of a proton. As we have found out, electrons and protons have a new property, and that property is what we call charge. So our next task is to study its properties. So charge is a scalar quantity. It means we are interested in the scale only. We are interested in the magnitude only. Charge does not have any direction. For example, if I have an object A which has plus 2 charge, and I have another object which has minus 1 charge. So if I combine these two objects, then the net charge on this combination will be plus 2 minus 1, that is plus 1 will be the charge on the combination. It means we can deal with charges just like as we deal with numbers. The second property is the net charge of an isolated system is conserved. So if I have an isolated system, its net charge will always be conserved. Charge can be destroyed, charge can be created, but net charge will always be conserved. For example, here I have a reaction. Here I have an electron which has a negative charge, and this is an anti-electron which is called positron sometimes, which has a positive charge. And when they come in contact with each other, they disappear and energy is released, and that process is called annihilation. So here I have charge, here I have charge, but on the other side I do not have any charge. So here you can see charges have been destroyed, but since this has minus 1 charge and this has plus 1 charge, so the total charge on this side is 0, the net charge on this side is 0, and the net charge on this side is also 0. So the net charge is conserved in this case. The third property is the charge of an object is quantized, where the word quanta means discrete packets. So if I want to charge an object, then I can charge it only in discrete packets. I cannot have a continuous flow of charge, because the charge on any object is due to electrons or protons, and generally the charge is due to electrons because protons are immovable because they are inside the nucleus of an atom. If an object has a negative charge, it means it has excess of protons, and if electrons, it has excess of electrons, and if an object has positive charge, it means it has deficiency of electrons. So if I have an object and I want to charge it, so if I give it 1 electron, then the charge on this object will be 1.6 times 10 to the minus 19 Coulomb. Or if I give it 2 electrons, then the charge will be minus 3.2 times 10 to the minus 19 Coulomb. But I cannot have the charge in between these two values. For example, in order to have charge of minus 2.4 times 10 to the minus 19 Coulomb, I will require 1.5 electron, and there is no such thing as half electron or fraction of an electron. Either I can have 1 electron or I can have 2 electrons. So it means I can give this object this much of charge, or I can give this much of charge, but I cannot give the charge in between these two values. So here I can have 1e, or I can have 2e, or I can have 3e, but I cannot have 2.5e or something like that. So it is often written as Q is Ne, where Q represents the charge of an object, E represents the electronic charge, and N should always be an integer. It cannot take any fractional value. Now let's talk about Coulomb's law, which gives us the force between two charges which are separated by a distance. So let's say I have two charges Q1 and Q2, and R is the distance between them. Then Coulomb's law states that the force between these two charges is directly proportional to the product of these two charges, that is, it is directly proportional to Q1 times Q2, and this force is inversely proportional to the square of distance between these two charges. It means the force is inversely proportional. That's why we write it 1 over R, and it is inversely proportional to the square of distance, so we have R square here. So after combining these two terms, we will get this F is directly proportional to Q1 times Q2 upon R square. Now, in order to remove this proportionality sign, we have to use a constant of proportionality. So here K represents the constant of proportionality, where in SI units K is equal to 1 upon 4 pi epsilon naught, and this whole value is approximately equal to 9 times 10 to the 9 per Coulomb square Newton meter square, where epsilon naught is called the permittivity of free space, and its value is 8.85 times 10 to the minus 12 Coulomb square per Newton per meter square.